So dear learners, let us try to understand the eccentric welded connection. There is a column flange. It is attached with the uh, bracket plate by means of the welded connection. The welded connection is shown in the next slide, and the size of the weld can be taken as 6 mm. This is a bracket plate. It is attached with the weld ISMB 400. The height of the weld is given as 320, and this is 140. 140. The load, we have to find the load P that is acting on the bracket plate. The load which can be transmitted safely through this weld, that we have to find. So we know very well this type of bracket connections are subjected to two types of stresses: direct shear stress. The other one is stress due to the torque testing moment. So we are calculating these two values. For that, first we are taking the size of the weld as 6 mm and throat thickness 0.7 is, so 0.7 into 6, 4.2 mm. So from this I am calculating the direct shear stress P by A. The load P, and A is the area of the weld. It is provided on the four sides. So we have seen the weld is provided on the three sides. So 140, that horizontal portion, 320 and 140 into 4.2. So that is the area of the weld which we have observed in the previous slides. So from this I am obtaining the direct shear stress P by 2520. You simplify this, you can get it. Next we have to find the maximum shear stress in the weld due to the torque. The formula is T by IP into R max. So we have to calculate one by one. First we have to concentrate on the polar modulus of inertia. For that we have to find the common center of gravity of the weld. Using the parallel axis theorem we are finding it. So A1 x1, A2 x2 for the vertical portion. Again for the horizontal portion of the weld, A3 x3. Then since we have got three segments in this welded portion, that is it is like this. So we can take three components, A1, A2, A3. So next we have to calculate this one by one. So what is the A1 and what is the X1 from this point? Okay. So this is X1 distance, X bar distance. So for this horizontal portion, first you substitute to 140 is the length and 4.2 is the thickness. 4.2 two times top and bottom, and the centroid would be lying at the middle, so 140 by 2. Next we have to calculate for this vertical portion. 320 into 4.2 is area, and almost it is lying in the same direction, so 0 divided by area of the two segments, so that is 32.67 mm. Next, so with this I can calculate the polar modulus of inertia. Ip equal to Ixx plus Iyy. So let me calculate the Ixx and Iyy. Ixx, so we have to calculate for this portion, Ixx for these three segments. So I self moment of inertia Ah square plus Iyy. For the vertical portion, Iyy is the moment of inertia. So you calculate this. This is 40.7 mm into 10 power 6 mm, mm power 4. Similarly, you calculate Iyy for the vertical, for the yy axis, about yy axis. So this is for the horizontal portion, and Ah square, and this is for the vertical portion into Ah square. So this value is 4.99 10 power 6. So let me add these two values. We can get Iyy plus Ixx will give the polar modulus of inertia. So from this you calculate tau max. So that value is R max is 192.67 mm. It's the extreme fiber distance. From this you calculate tau max. Tau max is equal to T into R max by IP. So T is a polar modulus for twisting moment, P into E. So E is the eccentric distance from the centroid. So you calculate R max and divided by IP, you can get the shear stress due to the twisting moment. So if you know these two values, you can find the resultant tau 1 square, tau 2 square, 2 tau 1, tau 2 cos theta. So you find the cos theta also. For this, finding the cos theta is very easy. This theta angle. So you calculate the theta by taking this opposite side by hypotenuse. So you can get 56. Next you substitute tau 1 square, tau 2 square, 2 tau 1. That should be less than the design strength of the weld, Fu by root 3 gamma mu. So Fu by root 3 gamma MO is 410 by root 3 gamma MO for weld is 1.25. So resultant stress should be less than this value. From this you find the safe load that can be transmitted, that is 111.15 kilonewton. So by this way we can design the eccentric welded connection. The only idea is we need to know, we should know how to calculate the polar modulus of inertia. Other things are very simple, so we can calculate it. Thank you.